Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.7, absolute. I knew something didn't look right there. Didn't catch it in the previous video either. Absolute value inequalities, video 4, greater than inequalities, part 2. Before we answer the two questions at the end of the previous video, let's quickly summarize how to solve an absolute value greater than problem. To solve an inequality of the following form, absolute value of an expression is greater than a number, with the number being positive. Rewrite the inequality as an OR compound inequality of the following form: expression greater than a number or expression less than the negative of the number. Just keep in mind that the first one is what you get when you take this guy and just lose its absolute value. And then for the other one, you just turn it around and take its negative, or however you want to remember. I like the visual. I have to live to the right of the positive or the left of the negative. Then you can continue solving and express your solution in interval form, as well as a number line. All right. So we're going to take a look at an inequality that's not in this form, but we're going to get it in that form and then solve it. So it's really not that difficult. You can probably figure out how it's going to go. Example, solve 4 is greater than 10 minus 2 times the absolute value of x minus 5. Well, this has a few issues. Number one is the absolute value is on the right side. We're going to want it on the left side so that it matches our form. And the second issue, which is a little bit more subtle, is the absolute value has a -2 in front of it. So at some point, we're going to divide by -2, which is going to reverse the signs. Let's start by solving this. Now, if we want to solve any type of problem, a general strategy is to isolate part of it so you can focus on it later. This being an absolute value inequality, our initial goal should be to isolate the absolute value by getting rid of the numbers attached to it. Now, this absolute value has a -2 multiplied in front of it, but that product is part of a subtraction problem, and so we have to get rid of the 10 first. Because the 10 is positive and we're getting rid of it in an additive nature, meaning we're not doing any multiplying or dividing with the 10, we're going to start by subtracting 10 from both sides. Let me change something real quick, folks. 1 second. Okay, I wanted to put the problem in the middle of the board, and I wanted to tighten up some of the spaces in there. Hopefully that'll make it a little bit more readable. All right, as I was saying, we're going to start by getting rid of the 10. So we'll subtract 10 from both sides so that we can cancel the -10 on the right. And what are we left with? We have 4 minus 10. Why did I cross it out? 4 minus 10 is -6, is greater than, the 10s cancel, and we have -2 times the absolute value of x minus 5. Getting closer to isolating the absolute value, we need to get rid of the -2 that's multiplied by dividing both sides by -2. That will give us the ability to cancel the -2s on the absolute value, but this is one of the moves that invokes the sign getting reversed. So the sign is going to turn around and become a less than. On the left side, we have -6 divided by -2, which is 3. And on the right side, we're left with the absolute value of x minus 5. Now, at this point, you might be saying, this is an absolute value less than problem, and it kind of looks that way. But remember that our strategy with the absolute value inequalities is to get them to look like absolute value on the left compared to a number on the right. We're currently at a number on the left compared to an absolute value on the right. When you have what I call a backwards inequality, only backwards because I would prefer my variable to be on the left, not the right, you can literally turn it around by changing the subject of the sentence. The sentence on the left here is, the subject is 3. 3 is less than something. That's like saying that the absolute value of x minus 5 is greater than something. So we can reverse this and say the absolute value of x minus 5 is greater than 3. And now this inequality has the form that we want. The absolute value of something is greater than a number. Let's take it to the next page and finish it. So the absolute value of x minus 5 is greater than 3. To solve an absolute value, excuse me, my name's floating around again. I'm not sure why. That happened before and I couldn't make it stop. Let me see if I can figure something. There it goes. Okay. To solve an absolute value greater than a number, you set the expression inside greater than that number, write the word or, and then say that that expression is less than the negative of the number. This is like saying that it has to be to the right of 3 or to the left of -3, which makes sense because absolute value measures distance from 0. Both of these are easy to solve. Add 5 to both sides of the first inequality. On the left, the 5's cancel, leaving an x greater than. On the right, 3 plus 5 is 8. Here's our or. And on the other inequality, x minus 5 is less than -3. If we add 5 to both sides, on the left side, the 5's cancel, leaving an x less than. And on the right side, -3 plus 5 is +2. As a number line, we would find 2 and 8, make sure they're in the correct order. X is greater than 8 means we shade to the right of 8. And because it says greater than and not greater than or equal to, we would use an open parentheses on the 8. And for x is less than 2, we would shade to the left of 2. And again, put a parentheses on the 2 opening to the right. Our interval from left to right is open parentheses, -infinity, comma 2, close parentheses, that's the left part of the number line, union, open parentheses, 8, comma infinity, that's the right part of the number line. So to summarize the point of this example, if you're solving an absolute value inequality and the absolute value is not isolated, get rid of the numbers attached to it. And if your absolute value is on the right, like it was down here when it said 3 is less than the absolute value of x minus 5, you can, and in my opinion, should completely turn it around and reverse the subject of that sentence. Instead of saying 3 is less than the absolute value, we can say the absolute value is greater than 3. All right, to conclude this video, we need to talk about the cases where that number is 0 and that number is negative. So let's start with the case where it's 0. What if the number is 0? Now, what happens depends upon whether it says greater than versus greater than or equal to. So let's start with the easier case. Let me pause it and set up a couple of problems. All right, we've got the absolute value of 2 is greater than 0 versus the absolute value of 2 is greater than or equal to 0. So what's the difference between the two? Well, let's start with the one on the right. The absolute value of x plus 2 is greater than or equal to 0. Why am I starting with that one? Well, think about absolute value as a function. And although we haven't really talked about functions, absolute value measures distance. Distance is never negative. At the very least, it's 0, but it's usually positive. So the inequality on the right says the absolute value of x plus 2 is greater than or equal to 0. But absolute value by definition is always greater than or equal to 0. It doesn't matter what number I put in for x there. When I'm done and I take its absolute value, the lowest I can get is 0. For example, if I put in, I don't know, x equals 3 here, I would get the absolute value of 3 plus 2 is greater than or equal to 0, which is clearly true because that's equal to 5, the absolute value of 3 plus 2. If I put in, say, -4 for the x, -4 plus 2 is -2, but the absolute value turns it positive, which is still greater than or equal to 0. The worst case scenario is whatever number would make the inside of the absolute value exactly 0, which in this case is -2. But even that works because -2 plus 2 is equal to 0, and the absolute value of that is still greater than or equal to 0. So in the case that you have an absolute value greater than or equal to 0, the solution will always be all real numbers. The solution to absolute value of an expression is greater than or equal to 0. I'll have to draw the or equal to is always, and I'm going to draw the interval as well. All right, so let me draw the or equal to underneath the inequality. But the solution to the absolute value of an expression is greater than or equal to 0 is always -infinity, comma infinity. Every number works. Now, what about the other one? What about the absolute value of x plus 2 is strictly greater than 0 as opposed to greater than or equal to 0? Well, that's true most of the time because absolute value almost always comes out positive except when it comes out 0. So if you have if you have an inequality of this form, well, let's just talk about this for a second. The only time this is not true is when x plus 2 equals 0. Because think about it. If x plus 2 is equal 0, then the absolute value ends up being 0. 0 is not greater than itself. Otherwise, x plus 2 is not equal to 0, so it's either positive or negative. And when you take its absolute value, it comes out positive, which will always be greater than 0. So the only time this first inequality is not true is when x plus 2 is equal to 0. So all numbers except x equal negative 2 are solutions. Now, what would that look like as a number line? Excuse me, as an interval? Well, you would start at negative infinity, comma, and you would stop at negative 2, close it with the parentheses, union, open parentheses, negative 2, comma, infinity. Every number except negative 2 makes this true. Now, if we wanted to generalize this, we could say something like the following. The solution to the absolute value of an expression is greater than 0 is all real numbers except solutions to expression equals 0. Since the inequality does not allow to be equal to 0. And I believe that wraps up this video and wraps up the video series for homework 1.7. If you have any questions, you know how to get a hold of me. Have a good day.